This is a review for the Pythagorean theorem and tangent ratio quiz 4.2. And I want to go over a few things that I noticed from the first take of the quiz. First of all, we have to make a distinction between the Pythagorean theorem and the tangent ratio. And one of the ways to look at that is to look at what's similar about them. So what's similar about using the Pythagorean theorem and using the tangent ratio and actually any right triangle trig ratio, what's similar is we have to have a right triangle. So before we decide whether we're going to use the Pythagorean theorem and the tangent ratio, we have to notice that and verify that this is a right triangle. Well, there are a couple of ways to do that. One, the simple thing is to see an angle marked 90 degrees. Or, of course, the way we indicate that is with a little square box in the corner, in one of the corners of the triangle. The other thing we can do, though, is sometimes we have to go back to geometry and use triangle sum. So perhaps the two acute angles are given, and we have to add up the two acute angles and make sure that the third angle of that triangle will be 90 degrees. But whatever the case, we can only use Pythagorean theorem and the tangent ratio when we have a 90-degree angle. And as we consider the Pythagorean theorem versus the tangent ratio, not only are there similarities, the similarity being they're used for only right triangles, there are differences. And the key difference has to do with what we're given. So let's consider the Pythagorean theorem first. To use the Pythagorean theorem, we have to be given only side lengths. Remember, the sides are the outsides of the triangle. They're measuring the lengths between the vertices or the vertexes. The numbers are always given on the outside for this. And that's what we're comparing the length of the hypotenuse with the sum of the lengths, the hypotenuse squared with the sum of the lengths of the legs squared. Remember to find the hypotenuse. First, you want to find the right angle, the box or the thing marked 90 degrees, or the angle we've calculated to be 90 degrees. I'm going to draw a little arrow to remind us that this is what we're calling C, and that stands for the hypotenuse. And therefore, C squared is equal to A squared plus B squared. The key thing I want you to get, and the main error I saw a number of students who had it set up correctly, but they forgot to put the C side, the side across from the right angle by itself in the equation. And that's going to tell me whether I'm going to add or subtract. Okay? So that's Pythagorean theorem. For the tangent ratio, we don't need all of the side lengths. In fact, one side length is enough so long as I'm given an angle. So what the tangent ratio does is it connects the measurements of the angles, and the angles on the insides, the relationship of the triangle looking from the inside, and is often given by this, we use this theta as a placeholder for the angle. And the tangent of theta is the ratio of the side opposite the angle. Here we could do the same thing. We could draw an angle or an arrow from theta all the way through the triangle to find out the side opposite. And the side adjacent, this number is going to be very close to where the measure for the theta is. So the difference is, for the tangent ratio, I need to be given some information about an angle. Or I'm trying to find a missing angle and I'm given two sides. So as we're looking at problems with Pythagorean theorem, deciding whether we're going to use Pythagorean theorem or the tangent ratio, what we're going to look at is what is given. So we'll start with what's given. So for example, if you look at this first problem, I'm given an unknown side and I'm given two known sides. And when I realized that the Pythagorean theorem only deals with the lengths of sides and there's no information about the angles, then I realized that this is a Pythagorean theorem problem because I'm given the length of two sides and no angles. And so I can set this problem up. Now I took little shortcuts on these because you all are pretty good at algebra and you can work your way to the final answer. But notice what we did. First, identify the hypotenuse as length 5, and I put 5 squared by itself. And then I make a sum of the squares of the other two sides. In this case, the side length 3 and the side length x. And then we realize in order to solve this problem, I'm going to have to subtract. If you do not place the hypotenuse in the correct place, that's the main error that I saw in the quiz. People just, I don't know how they're deciding what went by itself. But it's always this hypotenuse. Draw the arrow, put this side by itself, and then place the sum of the other two sides. This other problem is set up, is only giving me one side length, which would make me suspicious that I cannot use the Pythagorean theorem because I need two side lengths to do that. But I'm given an angle measurement. And so if I have a side length and an angle measurement, and notice what the side has to be, I do not have the length of the hypotenuse. It's not that it may not be given to me, but I don't need it for the tangent ratio. And that's very important. So the tangent ratio, I'm looking for one side, and I really shouldn't say side, I really should say one leg to distinguish it from the hypotenuse. One leg and one angle. So if I have a leg, remember leg is a side that's not the hypotenuse. So if I use a tangent, I say the tangent of 30 degrees, that's given here. The side opposite is going to be the length of 5. So the tangent of 30 degrees is equal to the length of the side opposite of 30 degrees divided by the length of the side adjacent to 30 degrees. And 30 degrees, so we write this out and we get 5 over x. Now then we have to be careful about our algebra. And some people set the problems up right, but didn't quite do the algebra right. Here, and I didn't show all the steps, but notice this x is dividing. So I multiply both sides and I bring the x over to the other side because I multiply both sides by x. Now I divide by the tangent of 30 on both sides and end up with this expression, x equals 5 divided by the tangent of 30. I put this all in my calculator. However, I know some of you like to find the number that goes with the tangent of 30, and that's fine. But just make sure we don't round at that point. Make sure you give at least 4 decimal places before you divide it by this 5. Okay? And that should get us pretty close to the answer. So what we want to do is evaluate, do I have sides or sides and angles? And sometimes I may have both, and then I get to make my own choice, which I prefer. So these are 4 practice problems. And what I recommend is you actually pause the video and look at this and make some decisions and write it on your own sheet of paper. So for example, number 1, we ask, which would you use, Pythagorean or tangent, and then circle the 1. And then, and I know I didn't leave space on my page to do this easily, but of course you work in your notebooks. Go ahead and find the value of x. What is x equal here? Same thing here. Decide, which am I going to use, tangent or Pythagorean? Find the value of x. Here's problem number 3. Pythagorean or tangent, use the value of x. And then on problem 4, I set it up. It doesn't matter which one you use. What I recommend is you do it both ways. And I'll warn you, the answer is going to be slightly different, but they'll be close to one another. And that just has to do with how I pick the numbers. Okay? So this one, I give you a tangent I give you an angle measurement in the leg. Here's my X over here, but I give you the hypotenuse as well. Okay, so like I said, pause the video, and then I'm going to put up the answer page, obviously, right after this. Here are the answers to the problems. Notice on problem number 1, it's Pythagorean. I'm given only 2 sides, and I find the answer is about 19.8. Number 2 is like that. Number 3 is obviously a tangent problem. Here I'm given an angle measurement in one side. And problem number 4, I did it 2 different ways, and I know it looks funny that I have slightly different answers. In fact, they're not close. If you ask me in person, I'll tell you why they're not exactly right. But if I gave a problem like this on a quiz, I would accept either one of these answers, and probably anything in between. Okay.